Okay, PS equals 2 into P0, P1, P2, that is the product of the three population, minus P1 squared, that is the first point you have selected, that is when T is equal to T1. Then multiplied by the sum of P0 and P2. P0 is the original population and P2 is the second point which we have considered, that is sum of that multiplied by P1 squared. P1 squared is the population of the first point, is it? Then divided by P0, P2. P0 is the again the first population 0 when it is T is equal to T0, multiplied by the second point, that is P2, minus P1 squared. P1 squared we know it is when T is equal to T1. And this m we have already written. M is the nothing but it is Ps minus P0 divided by P0. So this is the equation. And then n we can calculate. N is equal to 1 by T1 log E multiplied by P0 into Ps minus P1 divided by P1 into Ps minus P0. So this is the equation. And these three equations, it is the standard derivations of standard logistic curve equations. You have to learn these equations since in the examination usually they ask to set the curve, logistic curve, you have to derive the equations, or sometimes they are asking the question to calculate the population based on the logistic curve method. And in some of the textbook it is again these em, n, etc. It is again simplified in the other form. It is P equals Ps divided by 1 plus e to the power a plus bt. And again what is e, what is a and bt, b, a is equal to, a is nothing but log e Ps minus P0 by P0, and b is equal to 1 by n log e into P0 into Ps minus P1 divided by P1 into Ps minus P0, that is b. So if either this equation or this equation, these two equations you have to remember, then only you can do the problems. That is the standard logistic curves equations. There is nothing more to understand. It is the standard equations you have to learn, but you have to learn these equations and you have to do the calculations for population projection based on this logistic curve. And then next one is the graphical extension method. Graphical extension method, that is a simple one, it is a crude one, it is an approximate method only, that is from the known values of the decadal population you are plotting a curve. Then from the present population or the population which is known to you, from that particular point you are projecting the same curve in the same trend you are projecting, and you are calculating what would be the population in the end of the design period, or to which you have to forecast. That is the simple method. So this is not much accurate, only for initial calculation we are considering this extension curve. Then next one is the graphical comparison method. Again this is also not much accurate. Again this is to understand the trend in population projection, trend in increase in the population. For example, if you want to project the population of say Cochin city, or we are considering that the city will develop in the same manner as that of another city, that is for example another city of same demographic and geographic pattern. Demographic and geographic pattern, the demographic means it is of same death and birth rate, then the population increase in the earlier periods are of the same trend. And geographic, we know it is the geographical our land, is it the geographical conditions of our land or the city where we want to project the population. So then we are assuming that the population increase of Cochin city is of same